Student, welcome to Math Ninja Academy, and in this session we are going to focus on what we call implicit derivatives. When you talk about implicit function, we're just referring to a function which is not given in the form. Let's say a function which is not given in the form y is equal to f of x, where f of x is a function of one variable. Function of one variable. We call this implicit function. Implicit function is a function which is not given in the form y is equals to f of x, where f of x is a function of one variable. However, when you talk about implicit function, we're talking about a function which mix x and y variables in one equation. An example of an implicit function, let's look at example. We're talking about x squared plus y squared, which is equal to 7, for example. And then we can also think of, let me just give you something which is complicated. X squared sine of y plus y squared cos of x, which is equal to x plus y. We call these guys implicit function. So my objective for today is to take the derivative of this function here, to take the derivative of functions that contain x and y in the same equation. Ne? What you're familiar with is called explicit function. Explicit function, which is y is equal to x squared plus 2x plus 3. These are the example of explicit. Another example is when you have y is equal to x squared ln of x. You can see that explicit basically means that you're dealing with a function of one variable. However, when you talk about implicit function, we're dealing with a function which have both x and y in the same equation. So this is what we're going to do. But before we start with example, I think I'm going to use these two as our example. Before we start with the example, I need to give you a quick summary of how to take derivative of implicit function. Let's say maybe you have number 1, 2, 3, 4, 5. Let's say maybe you have d over the x of x squared, d over the x of x cubed, d over the x of y squared, d over the x of y, d over the x of a squared, and then d over the x of z cubed. Let's start with the first derivative. We have x squared and we are required to take derivative of x squared respect to x. What we're going to do here, we're just going to apply our power rule, which is going to be 2x. We are familiar with this. Similarly, we're going to do the same thing. We are given x squared, a function of x, and we are required to take derivative of this function respect to x. So our answer is going to be 3x squared. Okay, cool. Now we are given d over the x of y squared. One thing that we need to keep in mind is that we don't have a function of x. However, we are given a function of y, and we are required to take the derivative of function of x respect to, we are given a function of y, we are required to take derivative of function of y respect to x. So we're going to say 2y. However, we're going to multiply by dy over dx. So let's move to this one. We are given a function of k squared, and we are required to take derivative of k squared respect to what? Respect to x. So it's going to be 2k dk all over dx. Okay, The last one, we are given a function of z cubed, and we are required to take the derivative of z respect to x. So it's going to be 3z squared dz all over dx. I hope it makes sense, because we are going to apply this principle that I'm actually showing here in our next problem. Okay, let's do the last one. We are given a function of y, and we are required to take derivative of y respect to x. So it's going to be dy over dx, which is being multiplied by y, which is just dy over dx. Ne? And we're going to apply all these principles that I just explained now in these two examples that I want us to do. Let's start with the first one. I'm going to call it example 1. And you are required to determine dy over dx. Ne? What are you given? You are given y squared plus x squared, which is equal to 7. Ne? For you to take the derivative of this function, you are going to take the derivative of each term in this function. So let's take the derivative of each term in this function. So we're going to say d over dx of x squared plus d over dx of y squared, which is equals to 7. Ne? We know that now we are required to take the derivative of what? Of x respect to dx. So it's going to be 2x. Ne? Plus, now we are required to take the derivative of y respect to what? Dx. So our answer is going to be what? 2y dy over dx is going to be 2y dy over dx, which is equals to, oh, we need to take the derivative of this guy as well. The derivative of 7 is just going to be 0. Ne? And then what we're going to do, we're going to transpose this 2x to the right hand side. We're going to end up with 2y dy over dx, which is equals to minus 2x. Ne? If we divide both sides by 2y, is going to be dy over the x, which is equals to minus 2x all over 2y. The 2 are going to cancel out. What is left is minus x all over y, and this is your derivative which you were asked to take. Ne? Now let's look at the second example. It might look like it's a weapon formed against a degree, but it's actually a walk in the park. It's very simple, this one. So what do we have? However, this one requires us to apply the principle that we have been learning. Ne? So let's look into it. I'm going to try to be slow whenever I solve this one, so that we don't make unnecessary mistakes. So we are required to determine the y. We are required to determine the y over the x as well. Now this example 2, what are you given? You are given x squared sine of x sine of y plus y squared cos of x which is equals to x plus y. What did I say? First step, you need to take the derivative of each term. So we have d over dx of x squared sine of y plus d over dx of y squared cos x, which is equals to d over dx of x plus d over dx of y. Ne? What do we do after this? If you look at our problem that we're having here, you can see that here we have what we call the product rule. We have what we call product rule. Even here we have product rule. So what does product rule says? Product rule says that if we have y, which is equal to f of x, which is being multiplied by g of x, your y prime is going to be f prime of x. You keep the g, and then plus g prime of x, and then you keep the f, meaning that we can name this function as f, and then this one as g, this one as f, this one as g. So we're going to apply the same principle. What we're going to do now, we're going to take the derivative of f. Ne? So the derivative of f is going to be d over the x of x squared, and then what do we keep? We keep our g, which is sine of y, plus, now we take the derivative of g, which is sine d over dx of sine y, and then we keep our f, ne? Plus, we do the same thing here, we apply this rule here. We have the first function, which is f, so we're going to take the derivative of f, so it's going to be d over dx of y squared, ne? And then we keep the g, cos of x, plus d over dx of cos x multiplied by, you keep the y squared, ne? Which is equal to d over dx of x plus d over dx of y, ne? Now that we have applied the principle, what is left from us is just to solve these guys, ne? So now let's solve. What do we have? We have the derivative of x squared. What is the derivative of x squared? Is going to be 2x sine of y, ne? Plus, now we are required to take the derivative of sine of y respect to what? Respect to x, ne? Derivative of sine of y is going to be what? I'm just gonna first write the x squared, and then the derivative of sine of y is going to be cos of y, but since it's y respect to x, we're going to multiply it by the y over dx, ne? Plus the derivative of y squared cos of x, so it's going to be 2y cos of x dy over dx, plus the derivative of cos of x, we know what is going to be negative y squared, negative y squared sine of x, sine of x, negative y squared sine of x, which is equals to the derivative of x is 1, and then the derivative of y plus is going to be dy over dx, ne? So what we're going to do now, all the terms that they have x dy over dx are going to the left hand side, meaning that I'm going to be left with x squared cos of y dy over dx, ne? Plus 2y cos of x dy over dx minus dy over dx is equals to all these other terms. This one, this one, just gonna erase this. This one that I'm marking, the ones that don't have the y over the x are gonna go to the right hand side, ne? So what do we have on the right hand side? We have 1 is negative, it's going to be positive, plus y squared sine x, and then minus 2x sine of y. What we're going to do now, we're going to take the common factor of dy over dx, dy over dx, dy over dx. So dy over dx is going to be, we take it out, what is left is x squared cos of y plus 2y cos x minus 1, which is 1, plus y squared sine x minus 2x sine of y, ne? And then we divide both sides by all this nyaka that you see here. So our dy over our dx is going to be 1 minus 1 plus y squared sine x minus 2x sine y all over x squared cos y plus 2y cos x minus 1. This thing is long. You see, now we're starting to make unnecessary mistake. So yeah, this is how we get to the answer, and this is where we're gonna end for today. We managed to reach our objective, which is to get the y over x from the equation that we were given here, which it was implicit function. So all you have to do is the same thing we have been doing. All you have to do is just to apply this new principle that I just explained here, that whenever you are taking the derivative of y respect to x going to be 2y you multiply by the y over the x. Ne? At the end of the day, you need to make the y over the x subject the formula, and this is how you solve this guy. This is the end of our session. Please don't forget to like and subscribe and leave a comment if you like the video, or leave a comment if you have a question. And yeah, we'll meet again next time.